Dear students, starting first chapter, sets. In secondary section, in class 8, 9, 10, already you learn something about sets. Means some symbols, some elements of a basic set of numbers. You know that the first set I am taking is n. This is the symbol for the set of natural numbers. N is the symbol which is used for the set of natural numbers. Set of natural numbers or the set of positive numbers. The set of all positive integers. Positive integers. So this n contains 1, 2, 3, etc. up to infinity. This is the set of natural numbers. Set of all natural numbers. Second symbol, Z. See, Z is the set of all integers. This symbol is used for the set of all integers. Set of all integers, that means all positive as well as all negative integers. So Z is the collection of all positive as well as all negative integers. So -3, -2, -1, 0, 1, 2, 3 up to infinity. So this is the set of all integers. Set means a collection of well-defined objects. This is the collection of well-defined objects. Any collection of well-defined object is said to be a set. Third symbol, Q is the set of all rational numbers. Q symbol is used for the set of all rational numbers. Now what means a rational number? Which type of elements are contained in this set? So this set is defined as, it is set of all the numbers of the form P by Q, where P is any integer, Q is also any integer. P is any integer, Q is also any integer, but Q 0 is not allowed. So we can say that here P and Q both are integers where Q is non-zero. So correcting this statement, that where P and Q are integers and Q is not zero, Q is non-zero integer. So Q is the set of numbers of the form P by Q, where Q is non-zero integer, P and Q are integers. Restriction is for Q. As for example, say, if I say 7, now 7 can be expressed as 7 by 1. So here P is 7, Q is 1. If I take -15, -15 can be expressed as -15 by 1. So this is P, this is Q, this number is P, this number is Q. So 7 can be expressed as P by Q. Minus 15 can be expressed as P by Q, where P and Q are integers, Q is non-zero. So 7 is a rational. Minus 15 is also a rational. Means every positive integer, every negative integer is a rational. If we take 0, so 0 can be expressed as 0 by 5, or you can take 0 equal to 0 by 15, put 0 equal to 0 by anything. So this is P by Q. So 0 is rational. So all positive integers are rational numbers, all negative integers are rational number. 0 is a rational number. That means every integer belonging to this set is also a rational. Every positive integer including in this set is also a rational, like 7. So all integers are rationals. All integers are rational numbers. Now let me talk about non-integer numbers. If I take non-integer numbers, suppose if we take 4 by 5, so P is 4, Q is 5. This is non-integer, fractional. So because this is P by Q form, it is a rational. If I take minus 3 by 7, this is a rational. If I take 657 by 1000, it is a rational. So these numbers are rational numbers. Now, which numbers are not said to be rational numbers? Showing here example. See, if I take, suppose, square root of 2. Square root of 2 is not a rational. Square root of 3 is not a rational. If I take pi, pi is not a rational. These numbers are not rational. These are said to be irrational numbers. If I take, suppose, 3.1256210321625711098. After decimal point here, integers are continuing. Here there are infinite integers after decimal point. These are infinite integers. But nowhere there is a regularity. You cannot see anywhere repetition of a single digit or bunch of digit. As for example, suppose if I take, suppose 3.425, 425, 425, 425. If I write this number, then look here. After decimal point, there is a repetition of bunch of digits. So here you can see that repetition of bunch of digits. If you find repetition of bunch of digits, then it is a rational. This number is rational. See, if I put here, suppose 2 by 3, this is a rational, P by Q. Now observe this number. If I convert this in decimal form, then this will be 0.6666666. It will be continued. So see what is happening. After decimal point, there is a recurrence of 6. Here a single digit is recurring. After decimal point, from any place, if you find recurrence of a single digit or a bunch of digit, then such numbers are rational numbers. 2 by 3 is a rational, that means this is a rational. This is a rational. This number is also a rational number. If you observe, it's a decimal form. Decimal form of 4 by 5 is 0.8. Now see, 0.8. After decimal point, finite number of digits. If after decimal point you find a finite number of digits, say look here. Here I keep one more 0. Suppose this is 65787 divided by 10000. So what is its a decimal form? Its decimal form will be 6.5787. So after decimal point, finite number of digits, 4 digits. After decimal point, finite number of digits. After decimal point, if you find finite number of digits, that means it is a rational. But if you find after decimal point infinite number of digits, in which if there is recurring digit or recurring bunch of digits infinite times, then also it is a rational. So these numbers are rational numbers. These all are rational numbers. If any number is in P by Q form, if you convert in decimal point, after decimal point, if you find a finite number of digits, or if you find infinite number of digits with recurrence, then such numbers are rational numbers. But if in any number, if you do not find recurrence of any single digit or bunch of digits, neither recurrence of single digit nor recurrence of bunch of digit, which digit next will come, that we don't know. Here we can say, because 4 to 5, 4 to 5, 4 to 5, 4 to 5, here next will be 4, then it will be 2, then it will be 5. But here we can't say. Irregularity of digits. So this number is irrational. Square root of 2. If you find decimal form of square root of 2, then also in its decimal form, after decimal point there are infinite digits and no recurrence. So this is also irrational. This is also irrational. Mathematicians have found value of pi till 2 lakhs digits after decimal point. After decimal point, say you know that pi is 3.40. This is approximate value. Pi is not equal to 3.14. This is its approximate value. What is its exact value? So mathematician has found 2 lakhs digits after decimal point. As for example, I am putting here sequence of lump sum digits As for example, suppose digits are 3.141621631346009. See, this is nobody can remember 2 lakhs digits. I am putting random sequence. This is not exact value, but showing what is happening in pi. In value of pi, after decimal point, we remember only 2 digits because we need only 3.14 in calculation. But mathematicians have found 2 lakhs digits. More than 2 lakhs, up to infinite digits can be found. But in this decimal form, nowhere you will find recurrence, regular recurrence, neither recurrence of single digit nor recurrence of bunch of digits. That's why this is irrational numbers. So these numbers are irrational numbers. So any number, if any number is not rational, these are not rational. Means if a number cannot be expressed in P by Q form, this cannot be expressed in P by Q form, then it is said to be an irrational number. So rational number, irrational number. So remember terminology in mathematics. Sometimes symbol T is used. T is used for the set of irrational numbers. Then fifth symbol is R. This symbol is used for the set of all real numbers. Real numbers includes all rationals as well as all irrational numbers. R is the biggest set. It includes all rationals as well as all irrational numbers. So this was about set of numbers which we are using in mathematics. Now a set is a well-defined collection of objects. To understand this definition, a set is a well-defined collection of objects. Let us discuss these examples. Question is, which of the following are sets? Justify your answer. See, first example is the collection of all the months of a year beginning with the letter J. So say if we prepare this collection, the given collection is, it is the months of a year beginning with letter J. So which are months beginning from J? So these are January, June, July. This is given collection. Now if you ask any person from the world that give me 3 names of months or all the names of months beginning with J, then from person to person answer will be fixed. No change in this answer. Everyone will speak only these 3 names. So it means well defined. This is well defined collection. This is a well defined collection, so it is a set. Now second question, the collection of 10 most talented writers. Collection of 10 most talented writers. Now suppose if you ask this question to person, different persons, if you ask this question to 100 people, that prepare a list of 10 most talented writers. If I prepare a list of 10 most talented writers, then in the list of 10 writers, in my list, Chetan Bhagat is the most talented writer. But it is not necessary that you will also like Chetan Bhagat. It may possible that in your list there is no Chetan Bhagat. So person to person this will vary, depends on your choice. So this is not well defined collection. This is not well defined. Because person to person list may vary. So it is not a set. Therefore, it is not a set. Here this list will not change. This will remain fixed. But here it will be change. Person to person this will be change. Now here a team of 11 best cricket batsmen. Again similar example which I discussed here. This was example of 10 most talented writers. This is example of 11 best cricket batsmen. It may possible that in this list of 11 best cricket batsmen, if I prepare my list, I include MS Dhoni and you do not include MS Dhoni. So from person to person, list is different. So this is not a well defined collection. Not well defined collection. So therefore it is not a set. Next example is collection of all boys in your class. In your class, collection of all boys. If you prepare a list of all boys, name of all boys on a paper, suppose you are 25 boys in this classroom, and if I ask anyone to prepare a list of all boys, then see 25 boys are fixed in your class. So from you, anyone, if you prepare a list of 25 boys, your list will be same. So that means this is well defined collection. Collection of all boys in your class, that is well defined collection. So it is a set. It is a set. Now discussing methods of representation of sets. There are two methods of representing a set. First method is roster or tabular form. In this method, all the elements of a set are listed. All the elements of a set are listed. Means if we write a list of elements, then it is roster form. And second method is set builder form. In this method, all the elements of a set are expressed using their common property. Let us understand these two words in this example. Say here, question is, write following sets in roster form. we are going to write this in roster form. Now what means roster form? Roster form means in this method all the elements of a set are listed. Means we will prepare a list of elements in this method. Now see here, set A is it is set of all x such that x is an integer and x lies between -3 and 7. So this is a common property for all x belonging to this set. This is the set of numbers having this property. So this set in question, it is set builder form. In this method, all the elements of set are expressed using their common property. So all x are having this common property. So this form is set builder form and we are converting this into roster form. So now writing list of elements. Now see, x is integer, not all integer, not every integer, but integer between -3 and 7. So which are these integers between -3 and 7? So -2, -1, 0, 1, 2, 3, 4, 5, 6. So these numbers satisfy this property. So this is list of elements. So this set is expressed in roster form and given was, it was set builder form. So set builder form, this is roster form. Again, second example. B is the set of all x such that x is a prime number which is a divisor of 60. Prime number divisor of 60, that is common property. So here elements of this set are expressed using their common property. So this is set builder form, and now we are preparing list of elements satisfying this property. So list of elements set in roster form or tabular form. So set is expressed by a list of elements. So which are these numbers? Prime number and divisor of 60. 2 is a prime divisor of 60. So 2 is included in this set. 3 is a prime divisor of 60. 3 is included. 4 is not a prime. 5 is a prime divisor of 60. So 5 is included. Now because we need divisor of 60, if you think about other numbers, 6, 7 is a prime but not divisor of 60. 11 is a prime, not divisor of 60. 13 is a prime, not divisor of 60. 17 is a prime, not divisor of 60. 31 is a prime, not divisor of 60. So these are only the prime divisor of 60. So list of elements in this set, list contains these three numbers. So here elements are expressed by listing method. So this is roster form. Set is expressed in roster form and given was set builder form. Here set of all letters in the word trigonometry. Here property is given. Collection is defined by a property. That set of all letters in the word trigonometry. So we prepare a list of elements in this set. Collection of elements. So here in this set, T is included, R is included, I is included, G, O, N, then again O, but we do not repeat. In the list of element, every element we put once, one and only one time. We do not show here repetition. So once O is written, don't repeat it. M, still M is not included, so put here M. E, there is no E, so E is allowed. T, already T is taken, so don't repeat. R, already R is taken, so don't repeat. Y is not taken, so take Y. Now check this list. No repetition allowed. Every element is one and only one time. TRIGONMEY. So set of all letters of the word trigonometry. This is the set C in roster form. So when we show list of elements, order is not important. I can put here R, then second place T. You can set E at first place, or E you can put in last place. These elements you can keep in any order. Here order is not important. Important is that no repetition allowed. Now here X, D is the set of all elements such that X is an odd natural number. So this is a common property for all numbers in this set. So this set is expressed as set builder form. Now we are putting this in roster form. Odd natural number. X is odd natural number. So odd natural numbers beginning from 1, 3, 5, 7. Here we are not given any restriction that maximum of X or minimum of X. So we take all odd natural numbers. So all odd natural numbers show by dash 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 dash. So this set contains infinite elements. This is infinite set. This is finite set. Any set contains finite number of elements, it is finite set. Any set contains infinite number of elements, it is infinite set. Now in this question, write the following sets in the set builder form. So here list is given. List is given, that means we are given these sets in roster form. This form is given there. And we are asked set builder form. So we are going to express elements by a property. So see, here A is set of numbers 3, 6, 9, 12. You can see that these are multiple of 3. Multiple of 3. So we can express by common property by this way. A is set of all X. Set of all X. Now what is X? X is multiple of 3, that is 3n. But not all multiple of 3. So we put here restriction that this n is a natural number and not any natural. Value of n should be, if you put here 1, so begin from 1. So 3 into 1, 3. Put 2. 3 into 2, 6. Put 3. 3 into 3, 9. Put 4. 3 into 4, 12. 12 is the last by n equal to 4. So finish at 4. Because here we need only 4 multiples, so restriction for n is any natural number. N comes from n, but it is from 1 to 4. Similarly here, we put property for this set. B is set of all X such that. Now observe these numbers. These are power of 2. 2 raised to 1. 2 square. 2 cube. 2 raised to 4, 2 raised to 5. So x is 2 raised to n. And for n now we put restriction where n is natural number but not all natural. We take up to 5. So value of n begin from 1 up to 5. So putting here 1 we get 2, putting here 2 we are getting 4, putting here 5 we are getting 32. So n is from 1 to 5. Similarly, here these are power of 5, 5 square, 5 cube, 5 raised to 4. So this is the set of all x such that x is 5 raised to n. Power of 5 where n is a natural number but not every natural. N restriction for n is begin from 1, n raised 5 raised to 1, then last is 5 raised to 4. So this is set builder form. Then here D is, it is the set of all x such that x equal to, now we express common property. See, you can see that denominator is 1 more than numerator. Denominator is 1 more than numerator. So if numerator is n, denominator is n plus 1. Denominator is 1 more than numerator, where n belongs to n. If you put here 1, then 1 by 2. If you put 2, so 2 by 3. If you put here n equal to 3, you will get 3 by 4. What is last value of n? 6. 6 by 7. So n is natural but not any natural. N is 1 to 6. And see, if I change this question, if I put here dash 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 dash, if this is infinite set, elements are up to infinity on this pattern. There are infinite elements, so this is infinite set, then I should remove this restriction. Here elements are still coming, so here n equal to 1, beginning from 1 by 2, put here 2, 2 by 3, then put 6, 6 by 7, still they are coming up to infinity, so don't bound your limit. Say here n belongs to n. If you put here 1 crore, so somewhere there will be element 1 crore upon 1 crore plus 1, like that. So n is infinite set, putting all the values of small n, one by one putting all infinite numbers. Here we are getting infinite values of x. So this is set in set builder form.